So I'd like you to think back to the year 2000. Okay, so we're at the dawn of the internet revolution, and one of the only ways that people were able to design websites at the time was to write HTML code. So you had to kind of go there and write up some code, and then you'd have a website with links. And so one way to describe how human-machine interaction has come throughout the years is to describe a project that I had an opportunity to work on when I was at Berkeley at the time. And so this is the year 2001, where we designed a sketchable interface for people to actually make functional websites. And so as opposed to people sitting behind a computer screen and writing HTML code, we could then open up the human-machine interaction to a bunch of creatives who might be better at designing websites than pure kind of HTML computer scientists. And so here they're able to sketch out websites and then link them to each other and then zoom out and make a sitemap. And so this is just one way of how work in the field of human-computer interaction or human-machine interaction has democratized the way that people are able to interact with computers, from old punch cards and computers just doing zeros and ones, which they still do, to being able to interact with them in ways that are more natural to how we actually process information and convey information, in this case, in the design of websites. So if you go to the next slide, we can see how far we've come. So when I first learned about the invention of something like the Sketchpad by Ivan Sutherland in the early 60s, it blew my mind, because before that, again, people were just able to work with computers in a very constrained way, where computers were just computing. But in this case, it actually opened up computing so that people could start interacting with it through things like sketching. And so we take it for granted when we're able to interact with our cell phones, with our fingers, and in many cases with our digital assistants, with our voices, but we're standing on the shoulders of these giants. But we can think that there's a lot more that there is to come, right? And so if you fast forward 5 years from that, we now have a mouse. And so this was one of the biggest demos that they did up in San Francisco at the World Computer Conference, when they demonstrated the use of the mouse and the first instance of actually hyperlinks. And so being able to click on text and to go to other parts of an information scape. And so this was, again, something that blew my mind, because before this, things were just stored up in papers, and all we could do was conceive of information that wasn't interactive. And so if we fast forward now to where we are in the year 2018, we have wireless motion capture suits that are able to attach to all parts of our body, and we're able to interact in virtual worlds in ways that we wouldn't even be able to conceive back when we were just able to sketch at a minimum and then do things with a mouse. And now we're able to interact in virtual worlds and be immersed in ways that we would have never conceived. But there's still a lot more to being able to do in virtual worlds. And so if you go to the next slide, you can see that one of the other projects that I had an opportunity to work on when I was starting out in virtual reality. And so in the UC San Francisco Department of Surgery, they practiced a lot of minimally invasive cases. And so what you see here on the right is a laparoscope. And so a senior surgeon in this case is leading a hernia repair, for example, with a laparoscope that has a lot of biomedical challenges to being able to work it, but it also has some perceptual human limitations. And so things like seeing a 2D image on that represents three-dimensional anatomy on a monitor, and then the laparoscope having a really tough time giving you the actual force feedback of the anatomy. And so what we did, again, we're now a few years after 2000, where virtual reality is beginning to come to the fore. So if you go to the next slide, you can see one way that we designed a system that would allow junior medical students to be able to practice this skill. Again, so prior to this, there wasn't really any human-machine interaction in the context of surgery. People were able to practice these minimally invasive surgeries on animal models and other live tissue cases. And here it's somewhat of an augmentation or a supplement to that type of practice that inevitably they have to do, but they're able to do more repetitions in this kind of context. And so you can see the difficulties where the laparoscope, people hold it like they would a joystick, but then it's angled at the end. And so it's a pretty tough thing to master. It's a lot like cutting your hair in a mirror and kind of holding the clippers in the back of your head. And it's something much more difficult than that. And so if you go to the next slide, you see that relative to this actual surgical theater, when you look at the constrained, what I'll call solitary virtual environment, as an advanced technology it is, it's still missing many of the important social cues that come into play for these surgeons to become who they are. And so the senior surgeon and the junior surgeon are learning from each other, not just from the actual practices of doing the surgery, but the kind of social and cultural cues that go into this procedure. And so what I've done over the last 10 years in my career has been to expand kind of the solitary virtual reality that we've been practicing from the early 2000s to really look at the important social and cultural cues that we take for granted in our day-to-day interaction. But when we isolate them in the laboratory, we see just how important they are in shaping not only our perception of information, but in some cases our decision-making and our behavior. So if you go to the next slide, I'll give you one example of an experiment that we did in our group. And so what we've done is looked at a series of studies that has studied when in situations when virtual humans or intelligent agents are culturally aware. And so we've done this line of research with individuals who are bicultural. And so Chinese Americans, Iranian Americans, and Mexican Americans in our work. But we feel that there are other aspects of how this work can be important. So what we asked our participants to do in this study was to simply look at this picture and decide why the fish all the way to the right is there. So this task is called the causal attribution task. So we essentially asked them to decide what is the causal attribute for the fish being all the way on the right. So if someone can respond why they think the fish on the right is where it is.
He's bold.
He's bold. Okay, so he's volitionally taking it on him or herself to be all the way in the front. So thank you for that. This is what most people from individualistic cultures like our own in the U.S. would say. What's interesting is that individuals from collectivistic cultures from East Asia, for example, might give a more collectivistic causal attribution. Something like the school of fish is chasing the lead fish and causing it to kind of run away. And so that's another kind of on the opposite spectrum of what they would respond. And so what we did in the study is simply have people receive the instructions for the task from this virtual human. And so again, these are bicultural individuals. And in some cases we had an American control group who was born here and wasn't of a different ethnic background. And we had them listen to the instructions in either native California accented English or in a foreign accented language. And again, either Chinese accented English or Mexican American or Iranian accented English. And we asked them to answer a question of what I just asked you, but also to judge the appearance of what the virtual character looked like in terms of its ethnic affiliation, as well as what it sounded like. And so these are what we call manipulation check questions. We manipulated the study by adding an accent to it on an otherwise identical virtual character, and then we wanted to see, okay, do people actually perceive what we did as they did? What's not surprising is they perceived the accented virtual character as being accented, but they also judged the appearance of the virtual character to be more or less Asian when the character had either an accented spoken language or a non-accent language. They thought it to be more native. And so if you go to the next slide, I'll give you an example of what some of our participants saw.
Hello, and thank you for making time to participate in this study. Researchers at our institute design virtual agents, such as me, for use in training and entertainment applications. You are not timing this study, but we estimate that your participation should take less than 10 minutes at most. Before we start, let me summarize what you will do in the study. First, you will see a picture of a fish. Please indicate why you think one fish is swimming in front of the group. Second, you will complete some more survey questions. When you are ready, please continue to the next page of the study. Make sure to read every item.
So that was an example of what our participants saw, and as you can see from one of the figures in our work, the black bar on the left shows the Chinese American biculturals. When they hear these instructions from the Chinese accented character, they're more likely to decide that the fish is being chased by the other fish, whereas the same group, different participants who are Chinese American, when they heard the American accent, are giving more of an individualistic interpretation of the scene that the fish is leading. And so what we see here is that a social cue like accent that we take for granted and don't think that it's as important in shaping our interactions shapes our perceptions of the world, and in other work that we've done, shapes our actions and decisions of what we do in different contexts. And so if you go on to the next slide, I'd like to summarize by saying that the work that we're doing is helping to create these virtual characters that in many cases are becoming more and more culturally aware by sensing from us not only our cultural backgrounds, but in some of our work they're able to sense our physiological reactions when we interact with them in the laboratory for now. But what we see is this being more and more pervasive as technology progresses. And these characters are then able to take this information into account and reason about the environment and be expressive in ways that other humans are, and in some cases have more of a grasp of everything that's going on with their interaction partners than maybe other humans do. And so this is, again, how we can kind of rest assured that AI is progressing and in ways that we would hope would be for beneficial means. So we can have tutors and teachers or other types of role players in the place of virtual humans that can help us advance in different domains that we use them in. And so at this point, I want to turn it over to the organizers to see what else they have lined up.